then you can message me on there, or you can message me on Meetup or at class. All right, going into indexes now. A little about me. I've already talked about me a little bit, but you got to have one of these pages anytime you do a presentation. I have a few certifications. I was a database administrator. Now I'm a data engineer, which is just fancier. But I'm really, I just like saying it because engineer just sounds so cool, Snow Pro, which has nothing to do with Microsoft SQL Server. It has to do with Snowflake, if you've ever heard of Snowflake. And I don't mean as in the derogatory term in politics. Snowflake is a really, really cool data engine that exists in the cloud. We should definitely have, there's actually a Snowflake user group that started up downtown OKC. I haven't been to it, but I would encourage anybody interested in Snowflake to check it out. Snowflake is it's phenomenal. I know we talk mostly about Microsoft SQL Server. And to be fair, this is a data tool for analytics. It's not for transactional uses. So SQL Server you can use for transactions, right? It's always, you can be writing to it all the time. You can have it on-prem. Snowflake is not on-prem, and it doesn't do well with transactional stuff. You can import data to the databases that exist in the cloud, but it does better whenever you're doing bulk inserts or moving stuff from an ETL tool. We use Matillion a lot at my current job, but any ETL tools will really work. It has connectors for just about everything, and you can develop your own if you need them. But it has most of the big stuff. So it's really cool. You just, I know. So I'm a Snow Pro. So yeah, I'm pretty excited about that. So it goes on the page. And then I have blah, 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 just because this is really, it's just boring stuff. So let's just move on. Although Snowflake is really cool. We could definitely talk about, you guys want to just talk about, no, we'll talk about indexes. Maybe next time though. Okay. Before we talk about indexes, because this is sort of you don't know, the way that I wrote this or developed this presentation was from the perspective of, I don't know what an index is, or I've heard of an index, but I couldn't really explain it type of thing, for Microsoft SQL Server. So you gotta think about how your data is, where it lives. So, right, data is ones and zeros. This is written to something physically, right? So this is like really, really bottom layer stuff. It's stored on spinning hard drives or SSDs, and there's a lot of stuff is moving to the cloud, like I've talked to. Now you can have Microsoft SQL Server in the cloud on Azure. But even not just on Azure, you can put stuff on other virtual machines in the cloud, like on Amazon, on AWS. But typically, I'm most familiar with doing spinning or SSDs stored locally, right? So in your own data warehouse, either on in a data warehouse nearby or in your own data warehouse where your company is. The default, if you store your data and you create a new table, if you don't specify a clustered index, your data is stored as a heap. Okay, what is a heap? We'll talk about that in a minute, but just know that if you just create a table, it's going to be stored as a heap, because you have to actually define what your clustered index is. So for analytics, you can actually, your data gets pulled into memory. I wanted to include that on there just to sort of round out a little bit of the basics of how your data is stored. So in memory, memory is volatile, so that means that it doesn't persist, it isn't held onto, but it's a lot faster than spinning disks for sure, and even SSDs. It's way, way faster. And SSDs are getting pretty fast, but it still can't compete with memory, not even close. So what's really cool about whenever you do analytics, so if you're transforming the data a lot and you're playing with it and you're doing cool things, if you have it in memory, it goes way, way faster than you could possibly do on even the fastest SSDs. However, like we were talking about for the difference between an analytics tool like Snowflake in comparison to something transactional, you can't use analytics in that way for transactional stuff. You have to write it to an actual disk where it's going to persist, and then you can pull it out of that, and you can do work on it in memory. Okay. So let's just go over heaps to start off. Okay. So this means that there's no clustered index, which we'll dive more into. But basically, the way data is stored in Microsoft SQL Server is on a page, okay? And you can think of a page as a sheet of paper. If you just think about a sheet of paper and you wrote something down on it, that's how data is stored in SQL Server. It has these little virtual pages, and that's where the data is written most of the time. These pages are 8 kilobytes, and I want to say there's a header that's 96 bytes, something like that. But the point is they're about 8 kilobytes total, right? You can think about that as if you had an 8.5 by 11 sheet of paper, it's an 8 kilobyte piece of paper. You could think of it that way. It's just a page that stuff is written down onto. So whenever you think about 8 kilobyte paper and how it's stored, whenever you have an entry, you write that at the top of your paper, right? So that's the whole row. So you have one row with all of its columns, and you write that at the top of your paper. Then you have your next entry gets written in, it goes right below that, and you keep filling that out until your page is filled up. Okay, so that's how you would do that. That's how it works in Microsoft SQL Server. It writes and it fills up a page sequentially, down the page, it fills up the page, and moves to the next page, fills it up. Now, what that means is one column cannot hold data that is above 8 kilobytes, right? Because that's a whole page. You cannot have one row, one column, so one cell, right? You can think of it that way, that fills up the entire page and some. It just doesn't work. It gets stored in a different way that's not on a page, right? That's called large objects. Those are called large objects, or lob data, okay? That's greater than 8 kilobytes. Now, a row, which is a collection of different columns, right? So you could have 200 columns. That can exceed 8 kilobytes. But whenever that happens is it starts taking, I believe, the biggest columns first, and it writes them on other pages, and it has what are called pointers that points to other pages. So you might have a page, right, that has all this data on it, and you can think it's all got written down on one page, but it filled up the whole page, and there had to be more stuff that was written down. So it has a little marker on it that indicates what the other page is that contains the rest of the data, so you can go to that other page to find the data. Right, so this is just heaps, right? So this is, if you had a really, really big row that you wrote it down on, it would fill it all up, it would put some of the other data on another page with pointers to the other page or pages, and then it would keep doing that, and it would just keep going down, and new sheet of paper, think of it as a new sheet of paper, new page, page, just keep going down in a row like that. That is what happens if you do not create a clustered index on your table. Let me see if that was all that I wanted to talk about as far as some of the basic principles. Okay, I think that's most stuff. I might come back if I remember something else. So let's talk about clustered indexes, okay? Clustered index is not a copy of the data, it is the actual data, okay? So in a heap, that's just you have information, right? You have data, you wrote it down on your page. In a clustered index, it's the exact same thing. There is no heap either. It's not a copy of the heap. It's now this, but it's The differences between a clustered index and a heap is that there's an order, right? So there's a sort, okay? So this is sort of an interesting thing to think about, but you could have a bunch of entries, right, that start off with a number, a numeric column that just counted upwards, right? That just went 1, 2, 3, 4, 5, 6, 7. But if there's no clustered index, even though everything was in order, 1, 2, 3, 4, 5, 6, 7, all the way to 100, your SQL Server wouldn't know exactly where each row was in terms of what piece of paper or which page it was on. Conceptual piece of paper, right? So if you had each row took up one page, okay, so you had 100 pieces of paper, you had 100 pages, and you asked SQL Server, okay, and like I said, if you had it in a heap, so each row got inserted sequentially, right? So you had 1, 2, 3, 4, and you said, where is row 50, right? In a heap, your SQL Server would have to look through all of the pages and find, okay, here is 50. Even though it was written in a row, right? So it was all written it was all inserted in a row, 1, 2, 3, 4, all the way to 100. With a clustered index, okay, so you could create a clustered index on an exact copy of that table, right? And you sort it by that ID column, right? So you're clustering off of the ID column that went 1 to 100. Physically, the data is stored exactly the same. In this unique scenario, right, it's all put 1 through 100 in a row, but SQL Server knows where the data is in terms of whatever you're sorting off of, right? So it keeps in mind, okay, I know that this ID column goes 1 to 100. I know where I sorted and stored all these pieces of paper. It can just pull out number 50 and just take it and show it right to you. It knows exactly where it is. The way it uses that is what it's called using B trees. Okay, so what that does is, it's got some, I think it's got to be in the header, where it contains, okay, this is the set of data I have here. So if you had, and it's hierarchical. I think I had a B tree. Let's see. Just refreshing myself. Let's just click on the first one. I'm sure this will save. So make sure that you always click on links you're not aware of whenever you're being streamed, by the way. There's nothing that can possibly go wrong with it. So as you can see here, boy, can I zoom in? There, ooh, yes. I don't know if everyone can see that, but basically what's being stored here is that it knows, this shows exactly where the SQL Server knows where everything is. This is just a visual representation of what I was talking about. So this is hierarchical. You can see over here the different layers of the B tree. And this isn't going to be super technical, by the way, either. Just know that this is how it knows where all your data is. So in this scenario, it knows from the top layer, okay, I know that whatever record I'm looking for exists inside of this partition of my data, right? And then it looks down, and not partition in the SQL Server way, but this group of data, right, in this B tree. And it can further divides, it goes down choosing the appropriate paths because it knows where everything lives, and it can take you to your destination. So again, a kind of not super good way of explaining this somewhat technical idea, but just know that it uses B trees to find where the data is whenever you're using an index, okay? So what it means is it sorts things out and knows where everything is based on the sort, okay? In layman's terms. So even though your data might be stored the same, using a clustered index can help you get to wherever you need to go faster. So that's sort of most of the stuff I want to talk about with clustered index. Let's talk about non-clustered indexes a little bit, and then maybe we'll talk about a few examples. Non-clustered indexes, while similar to clustered indexes, they are not the same. A clustered index, like I mentioned before, is the data. It contains all the columns, right? So you can be sorted on a few columns. So like I said, ID, maybe you have it sorted by ID. So, but a non-clustered index doesn't have to be, or is not the table itself. It's a copy of the table, okay? So if you had a non-clustered index that had 100 rows, right? So you had all this data put into this table. I might have said non-clustered, into a table or a clustered index, right? So remember what I said, clustered indexes and tables, they are the same thing, right? So if you have a clustered index on a table, the clustered index is the table, right? So if you could have 100 columns in your clustered index. You could be sorting by ID, but you still have all the other columns there, right? So that's a lot of data, and maybe you're using more than one page to even store one row, like I talked about, right? Because you could have just a ton of data that's written to these pages. So if you're having a ton of data in these pages, you have to sort. The more data that you have, the more pages you have to read whenever you're pulling data back. Does that make sense? So if you have tons of data, even though it might be sorted by even the appropriate column, you still have to go through more data if you want to pull it back, because it's just written on more pages. There's more to write down. So if you have only one row per page and you need to pull back 50 rows, then you need to pull back 50 pages of information, right? So a non-clustered index, what you can do is you can say, well, I know that I only need a subset of this data. By the way, I switch back from saying data and data. Just don't be alarmed. It's just what I do, okay? You can take a subset of that data, and you can put that, it's written in a totally separate page, okay? So maybe you only want 5 columns on this table, right? Now the clustered index, like I said, is 100 columns, but you only want 5, right? And you're pulling back millions of rows. So it makes a difference, okay? Because one can be 10 times as many pages that you have to read off of than the other one. Right? So you might take a non-clustered index, and it could be the entire table too. You know what? I'm not going to get too distracted with that. Okay, so that's one use for clustered indexes, or one reason why you might need a clustered index is because you are pulling back too much data from you might need a non-clustered index, is because you're pulling back too much data from your clustered index. The table's enormous. You do not need that much data. Another instance in which you might need a non-clustered index is if you are using columns that are not being sorted by in the clustered index. Okay? So hear what I'm saying. If you're using a join or a specific column, like we can even use date if we wanted to. So you can imagine this scenario where I'm pulling back data from a table and you only want data that's been written in the past month. Now you can partition the data, that's one way of doing it. It's different, and it's not what we're talking about exactly. So what you can do is you can create a non-clustered index that sorts by the date, okay? Now, the reason why this is good, bumping that thing. The reason why you would want that is because if you're sorting by date, right? So if you're using a filter, if you're using where, then what you're asking SQL Server to do is you're saying, this is the data that I want, but I only want past this date. go look through all of the data that we have and only give me back the pages that have data past this date, right? So what SQL Server is doing there is called a scan. Okay, it's scanning all of the pages, right? And that is very difficult. Scans take really a long time because it means that every single page is being looked at by SQL Server. Okay, every page is being looked at. Now, conversely, if you had a non-clustered index where the data was being sorted by date, then it would have all the dates. So what that means, let's just think about what that means physically, right? So you have a page, it's going to write the data on each page in the order of the date, right? So maybe starting with the latest date, it's going to write down that, it's going to write down the next one, it's going to write down the next one. And if you wanted it to be ordered further, right? So maybe you don't care and it's just this date first, and you're writing down all of the data that's in today's date, and then yesterday's date, and then the previous day's date. Now you can even order it past that even. You could order it date and then ID, or date and then time, or whatever. But the point is that it's grouping all that data in a page format, right? So all of today's date are going to be written sequentially, starting, with today or whatever the latest date is, on the first page, right? So it's going to be all written sequentially, today and then yesterday and then the day before and then the day before that. So what that means is whenever I go to pull the data back, it's going to have less pages to go through. First off, because it's putting all of the dates together as much as it can on different pages. Instead of it being spread out over all the pages over all the data, it's only, it's being grouped, right? The other thing is it knows where those dates are in the headers. Like, so when we looked at the B tree thing a few minutes ago, it knows exactly which pages contains which dates. So it doesn't have to scan all of them and say, where are all the dates? Where are all the dates? Where are all the dates? It only pulls back the pages that has the dates it wants, or that the query calls for, right? So that's makes things way faster. So that's using seeks instead of scans, like I talked about already. It's only looking at the pages that it needs to look at versus all of the pages. And like I said, you don't have to include all the columns either. So maybe you only have 5 out of 100 columns, so it can fit a lot more data, a lot more rows per page, right? Because you're using 5 instead of 100, and it's grouping them all. So now you're even using less pages, and it knows exactly which pages to take from. I hope this is making sense. I now realizing maybe some more visualization would have been helpful for this sort of thing instead of me just sort of talking about it somewhat abstractly. But yeah. Now, let's say that you have a non-clustered index, right? That, like I said, is sorted by date, right? And you only have 5 columns. That can be all well and good, because what it's doing is, like I said, that's a copy of the table. It's a copy of those 5 columns written a certain way, okay? The problem with that is, if you are pulling back a query that uses, well, this would be a good thing, right? So if you're pulling back using a query that uses all 5 of those columns, great. It just goes straight to that copy, right? It goes straight to that non-clustered index, and it just pulls the data back off of those pages. If, however, you ask for a column that is not included in the non-clustered index, guess what it has to do? it has to use the appropriate clustered index, or it has to use the clustered index. I'm not sure if it will use another non-clustered index, but it has to do a scan on another index. Because it needs, if you try to pull back from the copy of the data, the non-clustered index, but you're missing a column, it's going to go, well, that's all well and good. I know where all the data is for these columns, but this missing column, I don't have that data. I need to go back to the base table, to the clustered index, and look through all the data that way and do a scan. Okay? So your non-clustered indexes, you want to have the right number of columns that, well, they'll get the maximum usage out of, okay? All right, let me ask this. Does this need a visual representation of what this looks like, or should I keep talking about this? Because I want to make sure that this is being communicated appropriately. And if it makes sense, then I can keep going. But if it's a little too abstract, then we can. It's actually okay, the question is, got to remember that. Is a non-clustered index like a snapshot of the data? So a snapshot I think of is like what the data looks like now, and we're going to store that. This isn't like that, right? Because now what happens is with non-clustered indexes, and this is a good question, is if I have a new row that's added to the clustered index, right? So to the table, I have a new record that's inserted, or I update an existing record, right? For every non-clustered index, the non-clustered index is a copy of the table, right? So if I write something to the clustered index and there's a copy of that column on a non-clustered index, it has to write that in 2 different locations, 2 different pages. So now you can think about, well, let's say I have 100 or 200 column non-clustered or clustered index. And so we're just pumping out a bunch of different non-clustered indexes because we want things we want to be writing, for our queries, we want them to be seeking the data, not scanning, because seeks are way, way faster, like I talked about. So you start writing non-clustered index after non-clustered index after non-clustered index because they help query performance so much. The problem with that is now, with every new non-clustered index, you're right for each of those columns that exist in the non-clustered indexes, it's multiplied by how many times they're used, right? So if you're using, if you have 100 non-clustered indexes and you write a new row, you're writing 100 times for wherever that row exists, wherever those columns exist in the other non-clustered indexes. Does that make sense? So it's not, a snapshot is more of like let's take a picture of what the data looks like now. And this is you're updating, if you update one thing and it exists in a non-clustered index, you're updating it there as well. You're deleting it from there as well. You're inserting there as well. Does that make sense? Indexes are really, really helpful, and they make things go a lot faster. Yes? Yeah, okay. Right, that's a good point. So a suggestion being made that I relate an index in SQL Server to an index in a book, right? So an index in a book, how that works is I need to know where this word is being used. So you go to the index of the book, right? That contains all that information. It says you go to page 246 to find this word. And then you just go, 246, I go straight there. Conversely, if you don't have that index in a book, right? You have to look through every single page. Where's this word? Where's this word? Where's this word? So you can think about that. That is a good point and a good example for that really is sort of how it works in SQL Server. Now, obviously, if you were looking for a single word in an entire book, it would take you a lot longer than it would SQL Server, but it still it can take way longer if you're doing a scan in SQL Server. And if I was more prepared, then I would have a demo set up. That would have been really cool, because it really, if you're using an indexer or not, it can be so much faster. And like I said, you can just imagine if you flip to an index, here's the word. I'm going to go find wherever that page is. It happens like that in comparison to flipping through every single page in a whole book. Randy, did you have something? Oh, Randy.
But I did have a question. Is there a set amount of data?
Oh, we're going to try the microphone.
Hi, Randy. Is there a set amount of data that warrants a non-clustered index?
Oh man, you're asking me for how big does the table need to be before I even start thinking about a non-clustered index? Which is a good question.
Is there a point in which a scan is faster than a seek?
Oh, I'm sure there is. Randy's like, all right, let me just flex my SQL knowledge on you over here. Okay, Randy, do you know? Can you tell the class if you know?
Well, I used to know. I think it was just a written number of pages, like 4,000 pages or something, but I figured someone might know.
This is a problem with growing up in the Google era. It's like, oh, well, I mean, why would I commit that to memory? No, but the point is well taken. So if you have a really small table, then you don't need to worry about writing a non-clustered index, because it's like, like I said, if you're, SSDs are so cheap, most people have SSD. Well, I wouldn't say most people. There's a lot of companies that are using SSDs, but even spinning disks that it just doesn't take long to look through every single page because there's not that many pages. So you can reorganize the data all you want, but it's like, well, it's going to take the same amount of time because it happens almost instantaneously whenever you do your scan. And that's Randy's point is, if you have a small table and you're like, whoa, which non-clustered indexes should I put on this? How can I make this faster? It's like, you're wasting time, your table's too small. And you can look up to, again, not information I have off the top of my head, but there are queries that you can run to see how many pages your clustered indexes are, how many pages your tables exist on. This also makes me think too, if we're thinking about everything written in pages and the indexes and looking up things faster, if you have large objects, right, so text and I think text is deprecated data type, but you can have bigger than 8 kilobyte column size. Those aren't stored on pages. It takes SQL Server a lot longer to look at that data, way longer. And I don't actually know, technically how it works. All I know is you start adding large objects on your tables. It's a really good way of making everything slow down a lot. Yeah. So, non-clustered indexes. You can actually find your SQL Server engine will actually, I think in every edition will, I don't know when this started, but will actually suggest indexes if it thinks that you need an index. Which is kind of nice. But you got to be careful. Like I said, if you start slapping indexes on everything, then your write times go up, so they can skyrocket. And if you have 1,000 databases that have crazy amounts of non-clustered indexes and you're writing to them all, now it's like, oh, why is my SQL Server totally bogged down all the time? It's like, well, you're asking for it to write. And even, like I said, SSDs, while you can, they're getting really good at reading and writing really fast, you still can bog that thing down if you exponentially start adding non-clustered indexes all over the place. So indexes, you have to be really careful because, like I said, it can make reading your data way, way, way faster, but you just have to be really careful and make sure you're implementing the right non-clustered indexes. And I'd like to talk more about this is like, there's so many rabbit holes that I could just talk down, go down and keep talking about, like how to create a good non-clustered index, because you want your clustered index to be wide enough, or your non-clustered, did I say non-clustered? Your non-clustered index to be wide enough to where it can be used by multiple different queries so that it encompasses other queries, right? So like you might have query A that uses only 5 of your columns in a table, and you might have query B that uses a different 5, or maybe it uses 3 of the same but 2 new columns, right? And you do that a few different times for different queries that are ran often, right? So you keep running the same queries. You want to have a clustered index, a non-clustered index that encompasses all of the columns, so that both of the queries that use, so that you can use 2 queries use the same index instead of 2 different indexes. Sorry, I know that's really confusing. It's not really confusing, it's just how I say it. But bottom line is you want to use the least amount of non-clustered indexes as you can and be efficient with it. And maybe in a future class we can dive into some examples, because you can, like I said, it can get really out of hand really quickly if you're not careful, and you could just start writing non-clustered indexes like crazy. What else do I have? Okay, so that's pretty much all I have. It's really simple stuff. Question?
Yeah, so you talk about how clusters can affect writing times.
Mm-hmm. Yes.
Do they also have a significant impact on restore times?
Well, right. So yes, they can. It all sort of depends. But if you think about a table, right, in a database, so you're backing up a database. The question was, can the amount of non-clustered indexes that you have on a table impact your restore times, which also would include backup times, so backups and restores. And the answer is you could affect it, because if you think about what a non-clustered index is, it's just copies of the data, right? So if you have a bunch of non-clustered indexes that are part of one table, and you have a bunch of tables, right, and all of them have a bunch of non-clustered indexes, you can quadruple the amount of pages that are being written to. Does that make sense? So the page is where the data actually exists, right? So a clustered index, it has all the data stored on the page, and then you're making a non-clustered index, that's a copy of that page, and then you have another copy and another copy, and before you know it, you got just way more pages than you started off with. And that all has to be backed up and restored whenever you back up and restore. So if it can be, it can definitely affect your backup and restore times. I don't know if I don't actually know how much it will affect your backups and restores. I guess it just depends on the size of your database. Yeah, I've never dealt with it personally where it's like, oh, the problem with this restore time is you had too many non-clustered indexes, but I definitely know that like it's just another thing to look at whenever you're cleaning up your SQL server, right? So I have the SQL server, it's bogged down, it's running slow as heck. What do I do? This wouldn't be the first step into cleaning up your SQL server, but it's definitely a step in cleaning up your SQL server, is reducing the extra non-clustered indexes that you have and not adding too many. Randy has a question.
Hi, Randy again.
Oh.
Just an idea, I just thought, if you're using SQL Server Enterprise, which allows you to build indexes online, if the amount of indexes truly impacted the restore process in a negative manner, it might be a better strategy to script out the indexes and drop them first, restore, and then build the indexes on top of it.
Yeah, you could do that. I'm wondering, that's a really interesting scenario that
I
I'm
got that from
thinking
Brent
of.
Ozar. He had a blog where he was showing the most optimal way to archive databases. So he basically script out all the indexes, everything,
that
dropped
makes
everything down
sense,
to its
because
most minimal level, and then compressed it.
that makes sense because you're backing up the smallest amount of data you possibly, like, because if you're archiving something, you don't need all the non-clustered indexes, there's just copies of the data. But if you need to restore that archive table and you need to use it, then you might need those indexes. So store the indexes, store the non-clustered indexes, script them out, but don't actually store the pages, right? Don't actually store the non-clustered indexes themselves.
Then you
It's
can
really
just run them
interesting.
later when you need it.
To be honest with you, I would doubt that going through all that effort would make sense in most scenarios in SQL Server. But it most likely, if you had a gigantic database that just wouldn't restore fast enough, you might want to look fundamentally on what's making the database so big. Maybe it just needs to be a really big database, or maybe you can split things off into other databases, things like that. Right, yeah. So, good question though. Apologize, it was a little bit more abstract than I thought it was going to be I've never given this presentation on indexes. I really like talking about them. I love talking about indexes, but boy, some nice visualizations would have been really helpful. But you live and you learn. This is what happens whenever you guys get to hear me talk over and over again. So let's get some volunteers up in here. Does anybody have any more questions? I'm sure that there's probably more questions than answers. But does anybody have any other questions on indexes? I will definitely like to dive in more on this stuff in the future, but I think we'll just probably call it for now if everyone's cool. Cool.